The AI for Good Global Summit aims to bring together industry leaders to try and harness AI to further the UN's development goals in areas like health, climate and sustainability.
How do we govern technologies if we don't yet know their full potential?
The main purpose of this summit is to explore how the AI solutions can help sustainable development.
AI will come to influence almost every aspect of our societies and economies.
AI 治理框架
AI for good.
I would say the most pressing topic at the summit is going to be how do you handle deepfakes, misinformation.
成为 AI for good.
Cumbre Mundial All for Good.
The good news is that the future of undetectable deepfakes can be avoided through the development and implementation of robust detection technologies and international standards.
Really seen as the fact that we can really affect amazing change, but we have to do this together and we have to do it in collaboration with partners, with organizations, with institutions, and that's what's making me so excited about what AI for Good is all about.
One-third of humanity remains completely offline, excluded from the AI revolution.
Artificial intelligence is changing our world and our lives, and it can turbocharge sustainable development.
We are the AI generation, and this is our moment, and it's our responsibility to write the next chapter in the great story of humanity and technology.
Andrea, you can go ahead. Thanks.
Hello, and welcome all to today's session. My name is Andrea Bonara from the ITU, the International Telecommunication Union, and I'm really pleased to introduce the launch of new problem statements for the third edition of the ITU Challenge. The aim of this competition is to solve real-world special problems by applying artificial intelligence machine learning to advance the United Nations Sustainable Development Goals and to build up knowledge in this domain. Since the second edition in 2023, we partnered with the Zindi Africa platform, and we had a successful competition with 5 problem statements and more than 1,500 participants from over 60 countries. I want also to remind you that in parallel to the GeoAI competitions, we also run the GeoAI Discovery channel, where we discuss GeoAI applications, including climate action, special digital twins, energy ecologies, agriculture, water, food system, health. More recently, this series is focusing on geospatial large language model and GeoAI education under the leadership of the curator, Maria Brovelli from Politecnico di Milano, and the chair also of the UN GeoAI Academic Network. If you're interested in this series and you missed some episodes, don't worry, you can watch the recordings of those events in YouTube or on the neural network to which you're connected right now. Let me now do a very brief presentation to introduce the ITU GeoAI challenges, which are organized in partnership with the UN GeoAI Academic Network and the UN Geospatial Network. So I will share my screen. Okay, if you can see my slides, I can begin. So the agenda of this session, I will introduce the competition, and then I will give the floor to Maria Brovelli, who will introduce the speakers from INEGI to introduce these two problem statements of vegetation mapping and human settlement protection. And then we will have an outlook of this moderated by Maria. So as I mentioned, the aim of the competition is to solve real-world special problems by applying artificial intelligence, machine learning to advance the SDGs. And you have the link to the website. Of course, we will make this available through the website. The benefits for participants is to have the disposal platform to gain and gain experience related to GeoAI, and therefore also an opportunity to define and shape technologies related to GeoAI. The benefit also is to be able to network and then get also global recognition from of prizes, appreciations, and may also be possible to have publications in IQ News Magazine and IQ Journal of Future and Evolving Technologies. For partners, is to have a visibility throughout the year, find the global talent, and also to find innovative solutions to your GeoAI use case. So I really hope that INEGI will find some interesting solutions. We award prizes for the top 3, and we award also certificates. For participants who don't have adequate computing resources, we also offer a platform with free GPU access. As I mentioned, we have a journal, and we are having special editions on GeoAI to advance the SDG. And so there is still time to submit papers. Then I put a link here with the solutions that are most of the time open source, so you can look at the solutions and documentation submitted in the previous competitions. We have a phase in which we discuss with the organization to find the problems, and then it's called the curation phase, and then the competition phase begins. And then we have an evaluation phase with the award ceremony in December normally. Just to show the competitions that were running last year from different organizations, the number of participants, and the one who submitted the solutions, and the number of countries which were involved. This year competition, so we are finalizing the last problems, while we have already 2 problems which have been already launched. And then you see the number of people who have submitted already solution, and only to show how it looks like on this leaderboard. So anyone can enroll and then can submit solutions. So in this case, we have the either who have submitted the 37 solutions, or always optimizing that. And so I hope that we will launch very successful competitions. And with this, let me stop the sharing of the screen. Right, and I can introduce now Maria Brovelli. Maria is professor of GIS at Polytechnico di Milano, and member of School of Doctoral Studies in Data Science at Roma La Sapienza. Amongst her many activities, Maria is Vice President of the Commission of Special Information of ISPRS, chair of the UN Global Spatial Information Management Academic Network, and co-chair of the United Nations Open UNGIS Initiative. I will now give the floor to Maria for introducing the speakers and moderating the sessions. Maria, the floor is yours.
Okay, so good day everyone. Welcome back to these webinars, and thanks, Andrea, for your kind introduction. Today we wanted to show you new challenges, and so this is very important, I believe, and very expected by many people. So let's dive into today's challenges, as I'm sure that our attendees are eager to learn more and get started on their solution right away. So first of all, these challenges are a bit different with respect to the previous one because they are proposed by, we can say, a committee of institutions. So specifically, the National Institute of Statistics and Geography, INEGI, of Mexico, the International Telecommunication Union, ITU, the AI for Good, which is this broad initiative, the United Nations Global Geospatial Information Management, which is called UNGGIM Academic Network, and the UN Geospatial Network are pleased to announce the launch of these new challenges, the two challenges. The winners will be honored at the prestigious UNGGIM 7 Eye-Level Forum, which will take place in Mexico City from October 8 to October 10 of this year. For those unfamiliar with this event, so the Eye-Level Forum, it centers on the theme of accelerating implementation, achieving resilience, and it is guided by the United Nations Integrated Geospatial Information Framework to advance the Sustainable Development Goals and address climate-related challenges. This Eye-Level Forum, so the 7th Eye-Level Forum, is hosted by the government of Mexico, and the forum aims to bolster global geospatial information management with a particular focus on developing nations. This event is part of the activity of the UNGGIM, and if you don't know who UNGGIM is, what UNGGIM is, it is a body which was established by the UN Economic and Social Council, so what is called ECOSOC, in 2011, and which serves as a committee of government experts dedicated to promoting geospatial information as a critical element of national and global infrastructure. The work of the committee includes coordinating geospatial activities, improving policies, and developing legal framework to address global challenges, starting from the point of view of the geospatial information. So at this point, given the significance of this topic and the esteemed committee overseeing them, let's turn our attention to the challenges. And before saying that, I want to strongly encourage students and professionals worldwide, including experts from mapping agency this time, to participate. This is a unique opportunity to address real-world issues using geospatial technologies, AI, machine learning, and at the same time contributing to the advancement and monitoring of the United Nations Sustainable Development Goals. Here, the details of the two challenges. So the first challenge is a challenge about vegetation mapping. Vegetation, we know, is essential to biodiversity, to carbon capture and storage, to soil formation and protection, and the regulation also of the water cycle. The Objective of this challenge is to propose and develop a robust and accurate machine learning model that can help to clean and improve training data, either identifying outliers, so wrong or suspicious labels, or even suggesting a more plausible label in the given data. The evaluation of these predictions will determine the winner of the challenge. Participants are expected to submit their final model along with its prediction on the test data, indicating outlier observations and desirably a suggested label. This first challenge is presented by Elio Hatenogues Villaseñor Garcia. Hello, Elio. Welcome. So good day, good morning, Elio. Welcome. So Elio is a data scientist with a master's in mathematics and a PhD in computer science from the National Autonomous University of Mexico. His research interests include machine learning, neural networks, data science application with high social impact. He is the leader scientist at the Data Science Lab of the National Institute of Statistics and Geography of Mexico. And so very welcome, Elia. And the second presenter is Jose Luis Ornelas de Anda. Jose is a biologist with a background in ecology from the National Polytechnic Institute. He began his career in 1981, played a key role in Mexico's National Land Use and Vegetation Mapping Program. He later helped transition INEGI's geospatial data from analog to digital formats, and he coordinated projects like the National Hydrographic Network. From 2012 to 2023, he was the leader of the National Mapping Program for Natural Resources, and in 2023, he shifted to research, focusing on developing advanced methods for vegetation and land use mapping by integrating deep learning, remote sensing, and geospatial data like Landsat imagery and digital elevation models. Okay, so very welcome, both of you. And now I give you the floor.
Thank you, Maria, for the introduction. Good morning, good afternoon, or even to everyone. It's a pleasure to be here, present the challenges of this great event. First of all, I would like to thank the organizers for considering INEGI as the proposing institution. We work in the research area of INEGI, especially in the data science laboratory. In this unit, we have made progress in leveraging alternative information sources and modern analysis methods to enhance the production of statistical and geographical information. We believe that these new sources allow for more efficient, timely production with a greater level of detail compared with traditional methods. Today, we will present two challenges that we face in our daily work. The first one is related to the construction of high-quality training data sets based on field surveys and human labeling. My colleague, biologist Jose Luis Ornelas, will provide more detail on this challenge, which is crucial as a preliminary step before applying machine learning algorithms. This challenge aims to develop a land use and vegetation map with greater spatial temporal resolution using machine learning methods and satellite imagery. And now, I turn over my colleague, biologist Jose Luis Ornelas, to explain further. Jose Luis, the floor is yours. Thank you.
Thank you very much, Elia and Maria, and good afternoon, good morning, everyone. I will share my screen. Okay. Can you confirm if you can see it?
Yeah.
Okay. Okay. Thank you very much. So, okay. Well, this is the challenge then. it is related to vegetation mapping, as you can say. Okay, well, in a very fast way, why is vegetation important? First of all, vegetation is just the whole set of plants in a given place. It is the base of all the food chain. Remember, plants are the only living things that can produce their own food using sun energy and CO2, carbon dioxide, water, and some nutrients. So it's essential for the energy cycle, the carbon storage and sequestration. This is related also to climate change, biodiversity. It constitutes the habitat for lots of species, form and protect soils, and also with the water cycle. So I took these pictures. It shows how the tree captures CO2 and water and produce food. That then this gyrif takes the food and it releases again CO2 and all that. And on the right, an example of how it regulates the water cycle too. Okay. Well, first, at INEGI, land use and vegetation maps have been produced for more than 40 years in a scale 1 to 250,000. It shows the spatial distribution of vegetation types for natural vegetation with primary or secondary growth, and it is also croplands, built-up areas, water bodies, and so on. It has been produced by visual interpretation of remote sensing imagery, and it involves a manual extraction of vegetation and land use features. This is critical. Of course, it is based also on field work, and it has had an updating cycle of about 5 years. There are seven versions of this map from 1985 to 2018. So well, the updating cycle has been very variable. This is a dynamic map that shows how the original vegetation was supposed to look and how it has been transformed or removed through the years. What it shows in white is not vegetated anymore. Okay, so about the scope and the current information needs. Okay, well, to start, there is not enough spatial detail. We mentioned before the 250,000 scale is just not enough. The updating cycle is too long. We need more frequent data, and we wish to achieve the monitoring. Another thing is that the classification and the interpretation is very subjective. So there are many errors and many inconsistencies. And so we want to have a more accurate maps. And we have to understand also the original objective. More than 40 years ago, it was just maps, printed maps on analog media, but now it has to be digital. Despite that, it has been the base, is information for many applications related with conservation, natural capital assessment, water sheds, agricultural planning, biodiversity, and so on. But what opportunities do we have for this? Well, one is people with domain knowledge about vegetation and field knowledge, here we can see some field activities. And of course, the enormous availability of remote sensing data from optical, radar, even LiDAR. For that, we have the Lancet and Sentinel archive, the open geospatial data cube. We also acquired the canopy height from GeoAI, which is a LiDAR on board the International Space Station, and more ancillary data, digital elevation models, bioclimate, and others. For our infrastructure, some robust workstations with NVIDIA cards, the open data cube that I already mentioned, and tools for development, Python, TensorFlow, Keras, and that. Okay. So what is the hypothesis? Each vegetation type is associated with the factors that determine it, mainly climate, relief, soil, and of course, land management. So the thing is that spectral reflectance properties and patterns. And so with that, we then go to that machine learning can detect complex multi-dimensional patterns. Well, you know better than this, than me, about approximating any nonlinear function, distributions in multiple dimensions, and that. Okay. So the data layers are a combination of Lancet and Sentinel imagery, which is called harmonized Lancet Sentinel, with Lancet. So all this has been standardized to Lancet, the Lancet bands at 30-meter resolution, diverse indexes for vegetation, for water, for soil, radar also from Sentinel-1, canopy height from GeoAI, relief from SRTM data for elevation, slope, aspect, and that, and bioclimate variables from working mostly. Here I can also add that the NDVI adds a temporary component, a seasonal. I mean, we have the medium and median values for the year, but also the minimum and maximum values. So that's very useful for evaluation of the phenology. Okay, as to the training points, there are about 265,000 sites. They have been labeled by visual interpretation on those variables that we mentioned, but also on very high resolution imagery and other, and also considering the other variables. So, well, okay, well, this is a view of all the sites. The present progress is we have the capacity to train models, so far a multi-layer perceptron, and then apply the trained model to derive the national geospatial data sets. But the current results are the accuracy goes from 55 to 75% is just not enough for a production map. We want at least an 80% accuracy. There are 123 categories between vegetation types and with ecological succession status, that is if it is primary or secondary growth, plus some land cover classes like built-up water agriculture. Okay. This is a view of one of the test maps at 30-meter resolution. Many of them have been produced from November 2022 to March 2024. Okay, so the challenge. So far, we have up to 70% estimated accuracy. The method is viable, but the limitations are mainly on the training data. They are very noise very noisy. So there are many errors, many inconsistencies. So the challenge is to take one portion of the training data, about 3,000 training data points from a single tile. Well, I will explain a little bit more later. So there is a set of original unrevised labels, well, the code labels for the vegetation or land cover, land use class, and a set of revised labels. They were that means that but for this area, the labels were revised thoroughly, although not exhaustively. So there may be errors also on the revised labels. And the set of feature labels with the spectral values, indexes, relief, climate, canopy, height, and all that they are in CSV files. And so the challenge is to develop a method that can help to detect outliers points. That means bad labels. Some inconsistencies are related with having this, for the same condition, different labels, or very different conditions with the same label. This comes from a very subjective visual interpretation. So the thing is to leverage the feature data to improve the classification, so to get more objective and based on measure features like the ones that we give, like spectral, relief, canopy, climate, and so on. And the final purpose it will be to develop a better map. Is not included in the challenge because only the data points are released. So, well, this shows the whole country with about 144 tiles, but we are giving only one tile. That's a big enough challenge. Okay, this is the Puerto Vallarta region. So many of you have heard of that, or probably some have been there. This is Puerto Vallarta. It's the Pacific coast. And there are some portions of the central volcanic belt of Mexico and also the western Sierra Madre, as well as the coastal plain of the Pacific coast. There is a lot of variation there, from tropical to temperate, from humid to semi-dry. There are mountains, there are coastal plains, and there is even a volcano with recent lava flows. It's about here. As to the vegetation cover, it goes all the way from mangroves, tropical, dry tropical humid forest, conifer forest, it's temperate forests, mountain cloud forest, and so on, and with very variable levels of disturbance, from completely transformed for built-up agriculture, some very highly disturbed because of land management, of forest fires, and so on, and surprisingly very well-preserved areas with forests that are more than 30 meters high in the canopy. So this shows the points, as you can see, probably on first sight, that there is not well balanced. And so there is a set of unrevised labels and a set of revised labels, and the featured values for 41 variables that we mentioned before: the spectral reflectance, the spectral indexes, all the others for relief, for climate, canopy height, and so on. So that's it. I just clarified that the labels are coded, so you don't see the descriptive label, but just a number from a catalog of 123 categories. So not all of that is for the whole country. The 123 categories. Maybe here there won't be the 123, maybe a little bit more than half of them, but just to keep consistency, the whole catalog was used. And basically that is the challenge. So we really need better training points. So thank you, that's all. If you have any question.
Thank you, Jose. It's a very intriguing challenge, I have to say, and yeah, very, very useful because can be reused everywhere, as a matter of fact. So, and it's also an original challenge, I have to say. So checking or finding, detecting outliers in the label. It's good because it's a bit different with respect to the other challenges we have. So thank you for your presentation. I invite also Elio, if you want Elio to come with us. Okay, so just to see if I understood correctly, there are the granularity from the spatial point of view is 30 meters because it's the harmonized Landsat CSAT. On the opposite, the true problem is the high number of classes of this point. So you said that we have, so the classification is with how many classes in the end?
Oh, okay, well, for the whole country, it's 123. But here may be around 60 something or that, but the codes are maintained as taken from the national catalog. So
okay. There is a question for you, a question from Gilberto Camara, and is asking if they can use time series of the harmonized Landsat CSAT data retrieved from the tile. It is open. So in my opinion, and therefore it is possible to check them, in principle can be used, but I want to have the answer from Jose and Elio.
Okay, well, there is not exactly a time series, but for the we prepared the data from the open data cube. So for example, for NDVI, we have the minimum during the year, the maximum, the mean, median, and standard deviation. So so that adds the temporal component, but it's not exactly a time series.
Okay, so I want to understand if beside these harmonized Landsat CSAT, but if there are other open data sets which were not proposed by you, but that can be used by the people who want to participate to the challenge. Is it possible or not? Because my idea is that if it is documented, everything is documented, and the data are open, and this is possible, but the persons doing that, what they did. Do you agree with me, Elio and Jose?
Yes, if there are suggestions for open data available, yes, definitely, yes.
Okay. Then another question from Lorenzo De Simone. Can someone participate as a representative of a team? Oh, I can answer to this one. Yes. Obviously, then the team will share the prize. So there is not one prize for every participant. The total budget is the same. So you need to share the budget with your team. A second question from Gilberto Camara. Can we use Sentinel-1 and Sentinel-2 data at 10-meter resolution?
Well, yes, if that can help to improve the training data, it's fine, but we haven't thought about using that for the whole country. The reason is this: although certainly for the base year that we have planned as 2018, we also want to go back in history to rebuild historical data, and that can be only done with Landsat.
Okay,
but if using a higher resolution data helps to improve the drive, that's very fine.
Yes, the only point is that they have to be open in such a way that everything is replicable, because we are dealing with something that is for everyone and can be checked by everyone. So we are dealing with something that is fair and can be replicable. Okay, thank you so much for this clear presentation. And for this intriguing challenge. With respect to questions, I want to go to the second challenge, I invite all the people who are interested in reach out to the presenters via email if you have, again, other questions. The general point is with respect to open data, you can use all the open data you want, but you have to declare to put the link to the website with the open data and say what you did with this open data. Okay, good. So let's go to the second challenge, which is about human settlement detection. Let us see the general introduction. Human settlements are rapidly expanding, creating an urgent need for efficient and accurate monitoring system to track and manage this growth. The objective of this challenge is to develop a robust and accurate machine learning model that can detect human settlement in satellite imagery. The task is to build a binary classification model that can predict the presence of human settlement in the given test data. The evaluation of these predictions will determine the winner of the challenge, and participants are expected to submit their final model along with its prediction on the test dataset. So this challenge is again presented by Elio, but we don't need to introduce Elio anymore because now we have known him, and by Ranier Rodrigo Suarez Ponce de Leon. Ranier Rodrigo is a data scientist specializing in the development of and application of machine learning models to address national challenges. His research at INEGI focuses on using this technique to enhance the understanding of Mexico. For instance, he has developed models to estimate demographic growth in different regions of the country and to monitor land use changes through satellite imagery. So I'm looking forward to hear also this second challenge. So Elio, now it's your turn.
Thank you, Maria. Well, the second challenge will be presented by my colleague Rodrigo, as Maria mentioned, and focus on the identification of new human settlements using satellite image. While identifying settlements through remote sense and machine learning is a relatively well-studied task, and in INEGI, we require very frequent updates of this information at a national level. Therefore, we need highly efficient methods that allow for rapid scanning of the national territory in search of new settlements. In recent years, we have made significant progress in this area, but we believe that through this collaborative challenge, we can find a method that is even more precise and efficient than the one that we have. As Rodrigo will explain, a specific training set along with a baseline model will be provided so that participants can improve the performance of our classifications. Now I leave you with Rodrigo for more details of this challenge. Rodrigo, the floor is yours. Thank you.
Thank you, Elio. Thank you, Maria, for the presentation. I'm sharing my screen. Can you confirm if you can see it?
Yes, we do.
I'm gonna put it in presentation mode. Hello, everyone. Good morning here in Mexico. My name is Rodrigo Suarez, and I'm very thrilled to have the opportunity to discuss with you this second challenge that is entitled Human Settlement Detection. First, as a disclaimer, I will be very brief, but I will go about the key points of this second challenge. First of all, as Maria just pointed out, it is crucial to have tools that allow for accurate monitoring the population growth, right? And these tools have to take advantage of the high frequency of the satellite imagery that Landsat or Sentinel satellites provides, right? So the challenge is fairly simple, is to develop a model that can correctly identify human settlements over these satellite images. Also, this model should be able to identify dispersed settlements that are not located in well-developed urban areas. This problem is a problem that INEGI has faced on the past, and we know by experience at the data science lab that these settlements that are not the so-called urban are fairly difficult to detect with fair accuracy. So some considerations about this challenge is that competitors will need to use data science techniques like normalization or balancing to create models that meet the requirements. So complex models are likely needed due to the nature of the dataset. The dataset is composed by millions of tiny images, so maybe complex models will achieve higher accuracy. Also, as opposite to the first challenge, competitors are free to transform the data that we will provide, but no other data source is allowed. So there's a restriction right there in the data. Of course, they can perform data augmentation and the traditional techniques, but they are not allowed to use any other sources of information, just the ones we are giving to them. So the goal is to obtain a model that correctly predicts human settlements in the landscape that uses only the satellite images. So how we collect this data? So we start off by a national grid that splits Mexico territory into millions of regular-sized tiles, right? These tiles are in the left image, colored in purple. So then when a census is performed, now we have in situ data. And with this data, we labeled the tiles that intersects with some kind of information, right? So now with these steps, we can label the tiles that have some kind of human settlement in their contain, right? So we end up with two subsets of these tiles that are labeled whether there is information of the census in that place or not. So, for example, in the second image, the tiles that are colored in green, it means that some kind of information of human source is presented, right? So, as you can see right here from the start, it's a binary classification problem where the goal is to detect the positive samples as there is a settlement in the region. Like I said, the goal here is to take advantage of the high frequency of the satellite images, but there is a common problem when analyzing phenomena by satellite images. Which image should I use when analyzing some phenomena, right? So the geomedian composite is the answer to that question. It's a composite that correctly represents what has happened in the landscape and has some desired qualities. For example, in the left image, you see the mean composite, the traditional mean that is used to convert n number of observations into one single image. So you can compute the mean, but the mean has a problem that is sensible and sensitive to weather, right? To noise. For example, here in the left image, you can see that it's very cloudy. So if you perform the geomedian that is in the right side of the slide, you can see the effect that the geomedian has over this series of observations, right? At the bottom, there is the formula for the geomedian, and as you can see, it's an optimization problem of finding a value y that correctly minimizes the distance on the complete series of observations. So this value y at the end is a synthetic value. That means it wasn't captured by the sensor itself, but has the characteristic that it correctly reflects what has happened in the terrain. So we match the geomedian composite for the corresponding year to the in situ observations and the labeled tiles. So the data extraction is to iterate over all the tiles and perform the extraction on the exact tile over the geomedian composite. For example, here in the slides, on the left hand, you can see there is a subset of tiles that are being labeled, whether 1 or 0, that is human settlement or not. And then with this subset of tiles, we extract the patches corresponding from the tiles, and that is going to be the data set itself. For this challenge, we perform the extraction over the Landsat collection. So at the end, we end up with multispectral images consisting of 6 bands, the traditional red, green, and blue, and also the near infrared and the shortwave 1 and 2. For this challenge, we collected for the training a set of 100,000 tiles labeled as inhabited and 1 million tiles from the uninhabited set, right? So at the end, the training will consist of 1.1 million samples that was collected all around Mexico territory. And in this way, we ensure diversity in the samples. Because as many of you may know, Mexico is a very heterogeneous country that faces a challenge in developing models, right? And for the testing, the inhabited samples are 60,000, and the uninhabited also is 60,000. So it's a balanced test set, giving a total of 120,000. As Elio mentioned, we will also be giving the participants a baseline models to have an idea of the problem itself. So we provided a Jupyter notebook with example of how to load the data and perform some operations such as balancing. As you can see from the previous slide, the training set is highly unbalanced, so you need to perform some balancing in order to achieve good accuracy. And we also included two state-of-the-art methods for machine learning, that is random forest and multi-layer perceptron. And I added this table just to show that if you go with vanilla models, you will have two classical effects in machine learning, that is overfitting and underfitting. In the case of random forest, you can see the training is way up to 1, and the test is fairly low, right? So you have a clear underfitting. And at the case of multi-layer perceptron, you see that it's underfitting the data. So this means there is a tricky patterns going on the data. So we provide these two baseline models just to participants to have a starting point. So the goal is to have a model that correctly predicts human settlements on the terrain, and the importance for INEGI is that this is the goal, right? This is the first step to automatization of updating this information, and not just update the information when census occurs. Census occurs every 10 years because they are very expensive to perform. So these kind of tools will put us in a position of correctly automatize the predictions between census years. So that will be all from my part, and the floor is yours, Maria.
Okay, so thank you. Also, this one is a very interesting challenge, and that can be replicated everywhere. So yeah, I have a curiosity, Ranyard, because you know that there are some predictors of the world population, like the World Pop database or the global human settlement layer of the European Commission. So I don't know if you already tried to compare your model and your solution with these global models, because they are global, with respect to Mexico. And but I understood that you want people not to add any other data, even if they are open, correct?
Yes, yes, that's right. We have compared in the past our results with public information or public models, but in this case, INEGI wants a model that is tailored only to Mexico, in order to correctly identify these settlements that are not developed in the so-called urban areas. And in parentheses, it will be like detecting more like informal settlements. So the need for a model that it is suited for Mexico needs, it is needed.
Okay, thank you. So this was my first question. I have a second one, because the training data set is not balanced. So we have 1 million on one side and 100,000 on the other side, correct?
Yes, that's correct, because the original samples, the ratio is almost 15:1 to the uninhabited to inhabited. So you can develop many data sets for levels that correspond to uninhabited. So we include a lot of these levels in order to have a complete sample of all Mexico's territory, and maybe the participants will benefit from this rich data set.
Okay, good. I see that there is a question from Lorenzo De Simone, can someone apply to just one challenge, or do we have to do both? No, you don't. You apply to one of them or either to two of them as you please. Obviously, if you apply to two of them, you have more possibility of winning, but that is it's possible to do what you want with respect to the challenge. The very important point is to follow strictly what are the recommendation of the people here proposing the challenge. So Elio, Rania, Rodrigo, and Jose. And so I see that there are no other questions, but I want just to give you some statistics. We have 225 people registered to this event, so a lot of people. So it means that there is a huge interest with respect to these challenges. Oh, there is one question, the last one, because then we will give the deadlines. So yes, Oscar Cardona Morales asks if there are any computational requirements for the models.
No, you're free to develop any model that suits your needs, whether if it is a simple model or a deep learning. You are free to develop any kind of model.
Yeah. I can add that what you have to do again is to document well what you did in such a way that what you did can be also replicated to see your solution. Okay, and so at this point, I believe we can give the word to Elio for the deadlines, because there is a challenge in these two challenges, which is the short time for providing a solution. So all the people interested, please be ready to start immediately working on these one or two challenges. And Elio will tell us everything about the deadlines.
Yes, thank you, Maria. I will share my screen. Did you see it? Oh, okay. Okay. Well, here are the important dates, or deadlines. Starting of the challenge is just this next Friday, 30th of August. And the deadline for submitting your solution is the 29th of September. Notification of the winners will be just after the deadline for submission in the next few days. And awarding date will be during the high-level group of GeoAI during the 8th and 10th of October 2024 in Mexico City. Yes.
Excellent. Yes. So at this point, I want to thank all the presenters, to say good luck to everyone. And please consider taking on this important challenge, because your solution could have a significant impact, potentially benefiting many countries and being adopted by numerous agencies. And so please don't be shy and participate. And now, in thanking Elio, Jose, and Rodrigo, I want to give the floor again back to Andrea for closing this session. So thank you so much.
Thank you very much, Maria. And I want to also to thank the speakers, Elio, Jose Luis, Rania, for this webinar, a very clear introduction to these two interesting problems that are all very relevant for the SDGs, and I'm sure that many of the scientists will be competing to provide the solution. I want to remind you that the presentations will be available in the neural networks. You can download them, and of course, you can watch again the recording on YouTube and the neural network. I thank you again, Maria, for having moderated this event and to our engaged audience for the active participation. So stay tuned for more exciting developments on GeoAI. And with this, let me give back the floor to Anna. Bye.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the eShop, and build your personalized AI for Good program. Let's shape the future of AI for Good.
The AI for Good Global Summit, convened by ITU, recognizes the joint responsibility of governments, the private sector, United Nations agencies, academia, and others to ensure AI reaches its full potential while preventing and mitigating harms.
And it's a moment that calls for action. And today I'm calling on each of you to use this summit to help the world to better understand what kinds of regulations, what kinds of guardrails we need to put in place right now. So together, let's make it innovative, let's make it safe, and let's make it responsible for all. Thank you very much.